Hi everyone, thanks for joining us today on this Ignite Summit. My name is Val, I'm one of the Apache Ignite Community PMC members, and today I would like to talk to you about Ignite 3. Ignite 3 is a project that started around a year and a half ago with kind of an overall goal of improving Apache Ignite platform, and I will clarify what it actually means in a second. Since the project started, we've come a long way. We've had several iterations of alpha releases, including Alpha 5, which has been just released, so be sure to download it and try it on your own. I've also talked about Ignite 3 exactly 1 year ago on the previous Ignite Summit, so today I would like to kind of refresh everyone's memory on what Ignite 3 is, why it exists, and also go through several major improvements that Ignite 3 is going to include and kind of compare it to Ignite 2.x, which is the current stable version of Ignite. All right, so let's start with the goals. There are two major goals that I would like to emphasize, and they both come from kind of the same reason. The reason is that Ignite 2.x has been out there for a while, for several years, and it went through significant transformation in terms of what the platform is used for and what kind of use cases it covers. Like, just as an example, Ignite 2.0, like the first version of Ignite 2.x, did not even have persistence. And it was a pure data grid solution, as opposed to the current Ignite 2.13, if I'm not mistaken, which can be used as a memory-centric database. It can be used as a pure in-memory solution. It can be used as a digital integration hub. It can be used for analytics. So it covers many more use cases as opposed to the first versions, but it never went through any significant transformation in terms of internal architecture or user APIs. And because of that, we want to accomplish two things. We want to modernize the platform, which includes replacement of some of the legacy internal protocols and some of the legacy data formats that we use in Ignite, and also make Ignite better suitable for cloud deployments, because we see more and more Ignite users transitioning from on-premise deployments to cloud deployments. And the second goal is usability improvement. This is about simplifying installation and upgrade procedures, just replacing the existing APIs with more modern and usable APIs, improving schema management, configuration management, and improving the operational aspect of the platform as well. So the first improvement I would like to talk about is kind of goes under the umbrella of modernization, and it's the new replication infrastructure. So in Ignite 2.x, we have kind of several mechanisms of replicating the data. We have the protocol that is responsible for replicating the data between primary nodes and backup nodes, which is kind of the main one, probably. Then there is the transactional protocol, which is completely independent from that one, from the first one. And then there is also the protocol, like a separate protocol for kind of the metadata that we have in Ignite. So it's kind of a zoo of different protocols that we have in the platform, and we wanted to unify that. And in Ignite 3, we're going to have this essentially a separate module responsible for that, and it will be responsible for all the data replication that happens within the cluster, and it will be based on Raft. So not only are we unifying all those mechanisms, we're also transitioning to this kind of, at this point, industry standard protocol for data replication. This brings multiple benefits, except for just the fact that it's, battle-tested, mathematical proven protocol instead of kind of a homegrown one. It also improves the split brain protection. It will provide kind of out-of-the-box segmentation, detection, and handling, and it will also help us to eliminate or probably at least minimize the amount of partition map exchange processes that we have, which essentially means better overall stability of the system. The second one is the approach to transaction. So first of all, this new transactional protocol that we're going to have in the system is going to be based on this replication infrastructure that I've just mentioned, which means that transactions kind of run on top of transactions instead of on top of the nodes, how it happens today in 2.x, right? That essentially means that we have a unified consistency model. We don't need ambiguity of atomic transactional caches. So whenever you update a single partition, it's essentially atomic mode. And whenever you have multiple updates within a single transaction, which go across multiple partitions, that's essentially equivalent to transactional mode in Ignite 2.x. But you don't need to have transactional caches or atomic caches like you have to do right now in 2.x. It's all transparent for you. It also means equal transactional guarantees for different APIs. So right now in 2.x, it's only key value API is transactional, SQL is not transactional. That's not going to be the case in Ignite 3. Both key value API, SQL API, and whatever other API that we might add into Ignite 3 will provide the same transactional guarantees as all other APIs. And also there is the new transactional API, which is quite exciting. It's fully async API, and it's in Java specifically. It's based on the standard completable feature, so it's easy to use. It uses standard language features, and it's also kind of integratable with different execution frameworks. In other languages and in other platforms, we're going to use similar approach. All right, so another aspect of modernization is pluggable storage. So currently, Ignite 2.x has only one single storage underneath. It's a B-tree-based storage, and it's utilized whether you have persistence or you don't have persistence. So we kind of utilize it even for in-memory only deployments. So we want to make it a little bit more flexible in Ignite 3. We want to have an option to introduce special kind of implementation of a storage for in-memory only deployments, or maybe also other implementations of the persistent storage as well, like LSM, for example, because there are different workloads that are better. There are workloads that are better suitable for B-tree implementation. There are workloads that are better suitable for LSM implementation. We want to give users the flexibility and the choice of between those different implementations. So we created like this whole infrastructure for pluggable storages. So there is a certain set of internal interfaces that can be implemented to introduce a new storage implementation into Ignite 3. And you can kind of mix and match several implementations within a single cluster in this architecture. And we also have our first implementation of the LSM storage, which is based on RuxDB, and we also have transitioned the B-tree implementation from Ignite 2.x. So you kind of, if you want to continue using Ignite 2.x B-tree implementation, you have that option, but you also have the LSM option based on RuxDB, and in the future we might add other options as well. Another thing is the new SQL Engine. This is actually something that we do both in Ignite 2 and Ignite 3. But it kind of started within Ignite 3 in terms of, Ignite 3 is going to get rid of H2 completely from day one. And it will use this Apache CLI-based engine for all the executions related to SQL. So this is basically just a replacement of H2 engine that we currently have with the CLI engine. Overall, CLI is just a better fit for this kind of use case. It's specifically designed for being a base for high-performance SQL database. That's what Ignite is. And it provides much more options for SQL support. So it's just overall wider SQL support, better optimization algorithms, and just higher overall performance and efficiency in terms of CPU consumption, memory consumption, and whatnot. So all those things I would put it under the umbrella of modernization of the first goal. Everything else would be under the umbrella of the usability improvement. And this is really exciting because the way we're addressing usability in Ignite 3 is really cool. And the first one is configuration management. So in Ignite 2.x, to configure a cluster, you essentially need to create a static XML file. That's at least the most prominent way of doing this. So you create a static XML file, you deploy it on every single node, and then it's being used by every single node. Those files are static, so it's really hard to update configuration parameters when we have those static files. There are certain knobs here and there for different parameters that you can dynamically update. But first of all, this creates inconsistency between the actual configuration in the cluster and those static files. that you have. So what happens if you restart the node, for example? That's a question. And also there is no consistency between those different procedures for different parameters. So we wanted to address this, and we wanted to do several things. First of all, we want to change the configuration format. We don't want to use XML, which is kind of a Spring-based XML, which Spring even doesn't use anymore. So we're switching to HOCON format, which is more kind of human-readable, JSON-based, and it's compatible with JSON. It's also compatible with Java properties, which is really cool because it helps us to update single parameters easier. And there is the whole framework around it for dynamic changes of the configuration, right? So there is a clear separation between static parameters that cannot be changed and dynamic parameters that can be changed. And for dynamic parameters, there is a clear procedure and clear API that will be provided to you. And also, that means that for dynamic configuration parameters, you don't need to restart the cluster, right? So that's kind of that's part of this whole configuration management effort. Schema management, but schema management is very tricky in Ignite 2.x. There are caches, which are essentially schemaless. You can put any objects in caches. Then there is binary object schema, which is created automatically and updated automatically when you serialize those classes. And there is also SQL schemas that are created explicitly by the user and provided in the configurations. That creates a lot of ambiguity, which we wanted to get rid of. And we essentially wanted to make sure that there is one-to-one mapping between tables and schemas. So if you have a table, you always can see what the schema for that table is. And when you update the schema, the data is being, consistent with that schema as well. And if you cannot update the data, to make it non-compliant with the schema, right? So you cannot, add something into a column which does not exist in the schema or something like that. Basically similar to what SQL databases do. This schema management approach is also a basis for what we call table API. So if you look at the examples that currently exist, and also there is a documentation page that kind of describes all those different APIs that we provide, there is the approach is that you create a table with a certain schema, and then you can create views on top of those tables. And this way you get SQL API, you get key value API, you get record API, and potentially other APIs that we might add in the future. But regardless of which API you use, the underneath mechanism of the schema management is always the same, and you always get those consistency guarantees between the data and the schema and the one-to-one match. So this is really cool in my view. It should improve usability of Ignite dramatically. Another thing is unified API. So in Ignite 2.x, we have client nodes, we have server thick clients, we have thin clients with a little bit different APIs. So we wanted to get rid of that in Ignite 3 and provide a single set of APIs regardless of where you invoke those APIs, whether you invoke them on the server side as a part of compute or as a part of service, or whether you invoke them as a part of the just client application. By providing the unified API, we make sure that there is no ambiguity between thick and thin clients, and we also provide these same interfaces on the server side and on the client side. And it's also based on the lightweight binary protocol, which is based on message pack, and it's much more implementable, so to speak, than the protocol in 2.x. So it makes it much easier to implement clients for all different languages and platforms. And finally, there is the CLI tool. This is probably the biggest usability improvement that I see in Ignite 3. This will provide essentially the entry point to all the Ignite functionality. When you download Ignite, you essentially have a single command, Ignite. And this command provides all the different management operations. You can run SQL queries from that CLI tool. It also comes with the REPL mode, where you just can connect to an existing cluster and execute those commands within those session, which also improve usability of the tool. All right, so that's basically all I have. These are the improvements that are coming in Ignite 3.0. So the other community members will now go through some of those improvements that I've described in a little bit more detail, and essentially discuss more in terms of how those features work internally from the architectural perspective and the implementation perspective. So you will hear about the pluggable stores, about the new SQL engine, as well as about the new CLI tool, where you will also see a demo. So stay tuned, and after these guys will finish, I will meet you all for a Q&A session. Thank you so much.